Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Nwaka. I am your instructor. Today, I'll be showing you the general arrangement of a hotel building. And looking at this right now, we are trying to perform a full structural design for this hotel building. And this hotel building is a high-rise building having a total number of floors of 30 floors and also 25 floors. So looking at this area right now, this area consists of 30 floors and this area consists of 25 floors. Now looking at the height of the building of this area, you can see that the height of this building is 120 meters high on this area of 30 floors, which also have a mini telecommunication mast at the top of the roof. And also on this other side for the 25-story building, it also has a height of 100.5 meters high, as you can see, which also have a mini telecommunication mast at the top of the roof, which controls all the signals for the hotel. Now, the name of this hotel is, as you can see it here, El Kahabi Hotel Building. So it is fully a high-rise building, which was sent to us by a client for us to perform the full structural design. And we have almost getting done with the structural design, about entering the structural detailing of this hotel building. So we chose that it would be nice for us to use it to also make a video, because as our culture is here on Ekidel, we always use a live project to perform structural designs so that anyone following our videos will be able to understand. And it's always good to use a live project to perform or to teach anyone you are trying to teach structural design. So with that, they can be able to understand what they are doing. Okay, now looking at this right now, since it's a high-rise building, it also has a consistent height of floor to floor height, as you can see it here. Only the ground floor that has 6.1 meters high, and the first floor has 6 meters high. And once you reach the second floor, it has a consistent height of 3.3 meters, as you can see here, consistent 3.3 meters, as you can see there. The same thing happens to this 25-story building also. Now, if we go to the plan view right now, this is the plan view that was given to us by our clients before we started performing the general alignment drawing, which means the column position. So this was how we got the plan, this building plan from the clients. As you can see, the ground floor here, which is scaled to 1:200, and also the first floor plan, which is scaled to 1:200 also, and also everything is being measured in millimeters, as you can see there. And also have this kind of staircase, which we will also use a software to design this staircase. Around this area, it will have a circular bin, as you can see it here, or simply call it a ring bin, which will also show you how to design this ring bin or circular bin in using the software Prota Structure. And this is also the ring bin area or on the ground floor. Now, looking at this also, this is that area for the ring bin. This is the place where that will have the ring bin, and it also have a dome structure, as you can see there, a dome structure, which we will also use a steel dome, a steel roof to perform this dome structure design. Okay, now also looking at this, you can see that it has a cantilever. The hotel has a typical cantilever length of about 1,000 meters, as you can see there. Has a typical cantilever length of 1.44 meters, and they are typical on both sides of the building, as you can see, 1.44 meters. Okay, and also it also have this mini telecommunication mast, as you can see there, which we will also model in the structural design. Now, the software that we will be using is not only Protastructure. We will use Protastructure to perform the full concrete design, and then we will use Tekla Structure to perform the steel design and steel detailing of these telecommunication marks, which we will have to export our Prota Structure model to the Tekla structure or Revit to now model this steel structure and then perform the structural design. Okay, so right now, as the culture is, which we have always taught you guys, that once a bidding plan is being given to you by a client and you are meant to perform the structural design, the first thing you are meant to do is to, first of all, understand the nature of the plan. So you must first of all try to understand the nature of the plan. What when I mean by nature of plans simply means, now looking at this right now, you have to consider what is this thing right here. And if you check at the first floor here, you can see that this is a staircase area. So with this right now, this I've told you that there should be a circular bin on this area, which was drawn by the design architect. And also looking at what he has given to us here, you can see that he has given to us an initial circular column. So this is the circular column that he chose, that if at all we are meant to use column to withstand the load on this area, we should use a circular column of this arrangement to give the building beautification. And also on this area too, because this is a cantilever of this side, you can see there. So he has given us columns, although the size of the columns now we now depend on us because we are the structural engineer. But he has given us that if you're meant to put column, it should be a circular column on at just as these positions. Okay, so right now, then also looking at this right now, you can see that this is not a concrete member, but this one showing a sky blue or a sky color is the concrete members. While these ones showing white colors are steel members. Now these steel members might not be a design steel members, but it can just be like let me say aluminum rails to just to guide all the people's movement using this structure. So with that, like this right now, you can see that this is like a glass, this is like a glass windows on this area, because if you look at what we have on this elevation here, you can see that this is like a glass window. So with that, now you have now identified that, oh, this place has a ray. Sorry, this is a ray, because once any user climbs this staircase, as you can see it here, and enters into this lobby, this is like a ray guiding them from falling out from this area. So you knowing all those things right now, that is what they call understanding the plan. So you're meant to understand the plan, and also you can see that it has a cantilever. So these are the things that you're meant to understand. So once you have understood all this, the next thing to do right now is to now go into performing the general alignment drawing. So this plan right now, you can see that the ground floor and the first floor, which is this one here. So this is the ground floor area, this is the ground floor elevation, and this is the ground floor plan, as you can see. And this is the first floor plan, and this here is the first floor elevation. So it's on the first floor that has that dome, that carries that dome structure, which is this one here. Okay, so right now, if now you now begin to think of where are the plans for these other rooms or these other areas. Now the plans of this 30-story area and this 25-story area here is now on this place. Just as if you look at this place, you can see that this is called typical plan from second floor to 30th floor, because this is our ground floor, this area here is our ground floor, and this area is our first floor. So the second floor starts from here. You can see that this is an extension of the first floor, which gives us this dome. So the second floor starts from this decking here. So now right now, this is now the plan of the second floor to the 30th floor. Now I will also attach this design file on my on this video description, so that if you want to follow up this design, because this design will take us at least 1 month to perform the full structural modeling and the design in Protastructure, and another 1 month to perform the full structural detailing. So I would say that if you want to be a good structural engineer, and then you want to carry the career of a structural engineer or a civil engineer to the highest level, or to at least to a greater level, I would say you should follow up with this model, with this design lesson, because you are going to learn a lot on this place, because there is a principle that follows that. There is a principle in designing high-rise building. As the number of your story increases, that is how you also decrease the value of your life load and your dead load. The value of your dead load begins to decrease also as the number of story increases. Then there is also what they call life load reduction factor, which I have not done with you guys that on this channel. But with this structure, since this 30-story building, we will have to apply life load reduction factor. As you can see that the story of this building is already 120 meters high. So at this height, there is what they call wind load. Wind load must occur on this building, which also we have already gotten all the wind data that will occur on the area, on the land or the terrain where this building is to be sited or constructed, and which we will also show you as we perform the structural design, and also the soil bearing capacity of this area. Although the soil bearing capacity of this area, this building is to be seated on a firm soil, on a very firm soil, having a bearing capacity of over 150 kilonewton per meter square. So, but the bearing capacity of this particular site for the soil where this building to be sited is 152 kilonewton per meter square. So, but as the soil is good, because this is a high-rise building, the only type of foundation that you can use or recommend is a deep foundation. And for the deep foundation, it is a pi foundation. So we will also use a pi foundation to carry this structure, where the pi foundation will be able to carry this building load to a suitable soil strata, which we will use a bolt pie and not a friction pie. So when we get to the pie foundation area also, I will also show you when to use a bolt pie and when to use a friction pie. So that is why I say this building is not just an ordinary building where you will just say, oh, I'm not going to learn. Because what you learned from our previous videos, which when we are designing for 1-story building, 2-story building, 8-story building, is not the same thing that will apply on this area. Because in the buildings that we have already done videos on, which is 1-story building or 2-story or 5-story or 8-story, we didn't apply most of the structural design guidance and principles which you are meant to know. But with this building, we will explain a lot and a lot. And like I said before you must enter to the stage of using software, it is important and necessary that you must have at least a manual knowledge of structural design and analysis. But because we do not have good engineers these days that spend time to teach the younger engineers, so they just go ahead to teach you software immediately without showing you the manual design. But here on Ekidel, while we are teaching softwares, we also apply the manual principles, because manual design is just all about principles. Once you know the design principles, in those days, there is something we call design Bible, where you have all the principles guided in it, just as you have the Bibles and you have Qurans. Qurans gives you guidance on how to follow Allah, and Bible gives you guidance and laws and rules and principles on how to follow God. So the same way, those days there's what they call design Bibles, which I still have today. So in that design Bibles, you will see all the guiding principles and what to do when you're designing for each particular structure, either for and also for when you're designing for some type of buildings, like for industrial buildings, hospitals and schools and many things. All those things consist of the guiding principles of what to use and how to apply wind load, when to reduce your life load and dead load. It is all found in that design Bible. Okay, so right now, you've once you get your plan like this, the first thing to do is to understand the features of the building. And once you're done with that, the next thing to do is now perform your general alignment drawing. Now looking at this plan right now, the first thing you have to you ask yourself, or where you have confusion, is you will begin to ask yourself, where do I start my column position, or which of the plan will I export to Prota Structure? That is where your question will come from. Because right now you have a first floor, you have a ground floor, and you have another type of from second floor to the 30th floor, have different shape altogether, and the building are being separated, as you can see it right here. So the first thing you ask yourself, and you also have the kind of plans also for kitchenette and all that, you ask yourself right now, where will I begin my GA, my column position, and my paneling? And which of the plan will I have to export to Prota Structure to begin my modeling? Now, this question, when we got this plan, this question came to our mind, and we used at least 15 minutes to study the building very, very well, and then we now come to a conclusion that we will not put our current position on this first floor or second floor plan, because if you export this to Prota Structure, you will only be able to model just this ground floor and first floor. But on this area, when you're trying to model this other floors from second floor to the third floor, and also this one, you will have issues. So the best decision we made was to use this to begin our general alignment drawing, which is the column position. And this one is what we will export to Prota Structure. Now let me show you right now how we did that. Now, looking at this below right here, you can see that we have already done a superimpose of this other second to 30th floor of these other two plans onto this our ground floor. Now, look at this right now. We didn't do our column arrangement on this place. We only copied the column arrangement that we did into this ground floor. Now, we are not going to export this ground floor to Prota Structure because it will give us issues when we are trying to model this particular site. So the question right now is, which one are we going to export to Prota Structure? Now, that takes us to this one here. Now, you can see how we did this right now. We only copied this plan right now, removed all the walls and just took only the grid lines, and then we find a particular reference point. Now, when you see this kind of plan, the first thing you must know is, where is the reference point? And a reference point is the point where every other stories are when you pick that point, you can locate every other stories at that same point. So when we look at this building right now, we notice that the reference point from the ground floor to the 30th floor is at this point, and this point. So this point right now is where all other stories will rest on. So this is the reference point for the 30th floor, for the 30 floors, and this is the reference point for the 25 floors. As you can see, this is the 30 and this 25. So this point right now is the reference point for this 25. So this is the center of gravity, or this is the center of building for this 25 story, and this is the center of building for this 30 floors, 30 story here. Now, so knowing that right now, we now understood that the first thing to do is to copy this plan and copy this one, and then superimpose it on the ground floor. So we now came to this place where we now have to copy out these plans, this second to 30th floor plan, and also this one onto this side, change the color, and then apply a block to make it a single unit, so that it can be easily copied as a single unit. So when we did this right now, we copied this right now using CP as a copy. Now we located the very point, which is the reference point that this building have with the ground floor. So we took it right now to this very floor here and placed it very point here too. Since this is the reference point here, so placed it at the point here. So you can see that the columns right now are passing at that exact point, as you can see it here. So this was the reference point which we now got. As you can see, the cantilever also can see it right here. So we also go do it the same way here and went and copied this other one also. Copied this one to using CP and located the and find the exact reference point and took it to the other side also on this place and placed it here. Okay, so this now gave us the two reference points, as you can see it here. So by the time we export this to Protastructure, this one here is the one, this one here, this particular one is the one that will go upward, and this one also will go upward. Why this one, as you can see here, only rests, these columns will terminate, these circular columns here will terminate at the second floor, because this is where those columns will terminate. So just not to cause confusion, we have to now change the colors of the columns that will terminate, which now leads us to this right now. So while we are performing the modeling, any column that has a magenta color, we're going to terminate at the second floor slab, as this is this very point here. So this is the point where all the columns that has magenta color, we're going to terminate at this floor, at this level, and also at this level. So these columns that has pink or magenta color, we're going to terminate itself at this very floor here. Why all these ones that are carrying green right here, we're gonna we transfer, we're gonna take itself directly to the roof, because as you can see it right here, all the columns that are showing on this green area is being transferred directly from wall to wall onto to the very roof, to the very last floor of this 30 story and to the very last floor of this 25-story building. So you can see how we have done the general element drawing. So we are about to now export this drawing right now to Protastructure to begin the modeling. So the reason why we didn't do a video of the GA of column position, because we have done a lot of videos on how to position your columns way before you perform your structural design, and we have taught you a lot on that. So the only thing right now we want you to do, because if we still begin to teach you every time how to position column position, how to position column on the reading plan before you now perform the structural design, you will not be able to have confidence on yourself on column position. So what we are going to do right now is just to help you to master column positioning, because as a structural engineer, you are the one to decide your column position and your distance of column, or your column distance. So just to help you so that you can gain confidence in positioning of columns, we will we will attach this CAD file to this very video description, and on that link you can download this file. Although, because here on EKDL, we teach everything, we give our knowledge for free. So just to be able to support EKDL to use at least to at least use to maintain EKDL, we will give this whole CAD file for $5. So if you want to follow up this plan, I would say that you should get this CAD file for an amount of $5, although we are still debating if we'll make it lower. But for now, that is what the management of EKDL have said, that they will give it out for $5, because this video alone will have a lot of materials which we are going to bring out for you guys, mostly to help you to understand structural design very well. But if you don't want to also get this CAD file, you can also watch the video, and then, because all our videos are for free, we are giving it out for free. We don't have any paid course. We are giving it out for free. Although if you want a special training or a special mentoring or mentorship on structural design, you can use our WhatsApp platform and chat us and message us on WhatsApp, and we will train you specially on structural design, but it won't be free, because that point now you're coming for a special training. Okay, so right now we are going to attach this card file to this video description, and if you really need that, we will give it out for free. And just to guide you also, although we are trying to debate if we will still leave these column positions, but because we want you to learn how to position your column, we are going to remove this column position that we have already done and give you just this raw card file here for the plan, so that when you get this plan, you will now position your columns. And then when you position your column, you can now watch the video and look at the guiding principles of column position that we have done in other videos, and position your columns. Then you can now have confidence on yourself. And if you're also having issues in column positioning, you can then send us a message on WhatsApp, where we will also tell you on what to do and how to go about it. Okay, so right now you can see now that we have got a lot of work to do. For the next 2 months, we are going to engage you on this design, and I will say to you, my very advice for you, if you really love Ekidel and you want to go far in your structural design life, I will say that you should follow up this plan, follow up this video lesson, because you are going to gain very well and gain a lot on this video. So thank you so much, and God bless you. Since this video is going to take up to 2 months to conclude, so we will be dropping this video series, each part once a week. So and this starts from this week, which is the first week of this is the first week of November 2022. So this video series will be concluded at 2023 January. That's when we're going to finish up this video design. So that's almost like 2 months. It looks as if it's long, but if you calculate the number of years you spent in the university studying civil engineering, which is up to 3 years to 4 years to 5 years, I would say that along all the line, while you're in the university, I am sure that nobody taught you this life example structural design, or use a life example life project to perform a design for you, and up to this standard, and up to this very massive structure. Okay, just to save time on this video right now, since I've already explained for you and tell you what we are about to embark on, which is this video series of the design of a high-rise building here on Ekidel. So we will now drop the card file for you, and then watch out for the next part, which is next week, which will now begin the modeling of this 30-story building. That's why we are attaching the card file and making it this distant time, so that anyone that we have uploaded, you will have time to study it and also practice. So you will take that 7 days interval to practice, and if you have any question regarding on what we have done on this building, you send us a WhatsApp message, and we reply you and give you clarification of what we have done. Okay, so thank you so much, and then God bless you. And also, if you find Ekide very, very useful and it had helped you a lot, I would say that you can support us in any way you can, by maybe sending your super thanks, or sending your help using our donation link. We also have our link for donation, which you put any amount that you want, and then we say thank you so much, and we appreciate all that you donate. So God bless you, and then thank you, and watch out for the next video, and then we love you all.